Hello everyone, the topic today we will be discussing is types of problem solving strategies. The main objectives in this lesson are to understand problem solving strategies, types of strategies, algorithms, and we look at heuristics and biases. A problem arises when one has a goal, a state of affairs that one wants to achieve, and it is not immediately apparent how the goal can be attained. A problem consists of a given state, that is a description of a current situation, a goal state, that is a description of the desired situation, and a set of operators, that is rules or procedures for moving from one state to another. A problem occurs when a situation is in one state, the problem solver wants it to be in another state, and there are obstacles to smooth transition from one state to the other. So, problem solving is the application of ideas, skills or factual information to achieve the solution to a problem or to reach a desired outcome. In cognitive psychology, the term problem solving refers to the mental processes that people go through to discover, analyze and solve problems. This involves all of the steps in the problem process, including the discovery of the problem, the decision to tackle the situation, understanding the problem, researching the available options, and taking actions to achieve your goals. Before problem solving can occur, it is important to first understand the exact nature of the problem itself. If your understanding of the issue is faulty, your attempts to resolve it will also be incorrect or flawed. We solve hundreds of small problems every day. People face problems every day, usually multiple problems throughout the day. Sometimes these problems are straightforward. For example, to double a recipe for a pizza dough, all that is required is that each ingredient in the recipe be doubled. Sometimes, however, the problems we encounter are more complex, like say you have a work deadline and you must mail a printed copy of a report to your supervisor by the end of the business day. The report is time sensitive and must be sent overnight. You finished your report last night, but your printer will not work today. What should you do? First, you need to identify the problem and then apply a strategy for solving the problem. When you are presented with a problem, whether it is a complex mathematical problem or a broken printer, how do you solve it? Before finding a solution to the problem must be clearly identified. After that, one of many problem solving strategies can be applied, hopefully resulting in a solution. We must have the ability to solve different types of problems using different types of solution strategies. So now we see what are the types of strategies. A problem solving strategy is a plan of action used to find a solution. Different strategies have different action plans associated with them. Problems themselves can be classified into two categories known as ill-defined and well-defined problems. Ill-defined problems represent issues that do not have clear goals, solution paths, or expected solutions, whereas well-defined problems have specific goals, clearly defined solutions, and clear expected solutions. Problem solving often incorporates pragmatics, that is logical reasoning, and semantics, that is interpretation of meanings behind the problem. And also in many cases, it requires abstract thinking and creativity in order to find novel solutions. So, within psychology, problem solving refers to a motivational drive for reaching a definite goal from a present situation or condition that is either not moving towards that goal, it is distant from it, or it requires more complex logical analysis for finding a missing description of conditions or steps towards that problem. Processes relating to problem solving include problem finding, also known as problem analysis, problem shaping, where the organization of the problem occurs, generating alternative strategies. Depending on the type of problems, you have a lot of options regarding possible solution strategies. The following are the common strategies for well-defined or routine problems. The first strategy type, that is trial and error, which means continuous trying different solutions until problem is solved. For example, restarting phone, turning off Wi-Fi, turning Bluetooth in order to determine why phone is malfunctioning. The second strategy type, that is algorithm, which means step-by-step problem solving formula. For example, instruction manual for installing new software on your computer. Now let us discuss these strategy types in detail. The first one, trial and error, that is mechanical solutions. One method is to use trial and error, also known as a mechanical solution. Trial and error refers to trying one solution after another until finding one that works. For example, if Sheila has forgotten her PIN number for her online banking websites, she can try one combination after another until she finds the one that works. If she has only a few such pins that she normally uses. Mechanical solutions can also involve solving by rote or a learned set of rules. This is how word problems were solved in grade school. For example, one type of rote solution is to use an algorithm. Algorithms are specific step-by-step procedures for solving certain types of problems. Algorithms will always result in a correct solution if there is a correct solution to be found and you have enough time to find it. By following the instructions correctly, you are guaranteed to arrive at the right answer. Algorithms are used frequently in our everyday lives, especially in computer science. When you run a search on the internet, search engines like Google use algorithms to decide which entries will appear first in your list of results. Mathematical formulas are also algorithms. When librarians organize books on bookshelves, they use an algorithm, that is, place books in alphabetical order within each category. For example, many puzzles like Rubik's Cube have a set of steps that, if followed exactly, will always result in solving the puzzle. It can also be understood by taking an example of cooking a new recipe. To cook a new recipe, one reads the instructions and steps and execute them one by one in the given sequence. The result thus obtained is the new dish cooked perfectly. Similarly, algorithms help to do a task in programming to get the expected output, as one would not follow any written instructions to cook the recipe, but only the standard one. Similarly, not all written instructions for programming is an algorithm. In order for some instructions to be an algorithm, it must have the following characteristics. Now, if we look at the chart on the screen, there are certain characteristics of an algorithm. The first characteristic is clear and unambiguous. Algorithm should be clear and unambiguous. Each of its steps should be clear in all aspects and must lead to only one meaning. The second characteristic is well-defined inputs. If an algorithm says to take inputs, it should be well-defined inputs. The third characteristic, well-defined outputs. The algorithm must clearly define what output will be yielded, and it should be well-defined as well. The next characteristic is finiteness. The algorithm must be finite, that is, it should not end up in an infinite loops or similar types. Next, feasible. The algorithm must be simple, generic and practical such that it can be executed upon with the available resources. It must not contain some future technology. Next, language independent. The algorithm designed must be language independent, that is, it must be just plain instructions that can be implemented in any language, and yet the output will be same as expected. Now we will see some of the uses of these algorithms. The upside of using an algorithm to solve a problem or make a decision is that it yields the best possible answer every time. This is useful in situations when accuracy is critical or where similar problems need to be frequently solved. In many cases, computer programs can be designed to speed up this process. Data then needs to be placed in the system so that the algorithm can be executed to come up with the correct solution. Such step-by-step approaches can be useful in situations where each decision must be made following same process and where accuracy is critical. Because the process follows a prescribed procedure, you can be sure that you will reach the correct answer each time. The downside of using an algorithm to solve the problem is that this process tends to be very time consuming. So, if you face a situation where a decision needs to be made very quickly, you might be better off using a different problem solving strategy. For example, a physician making a decision about how to treat a patient could use an algorithm approach, yet this would be very time consuming and treatment needs to be implemented quickly. In this instance, the doctor would instead rely on their expertise and past experiences and to very quickly choose what they feel is the right treatment approach. But algorithms aren't always practical to use. For example, if Sheila didn't have a clue what those 4 numbers might be, she might be able to figure out her forgotten PIN number by trying all possible combinations of 4 digits, that is from 0 through 9. She would eventually find the right 4-digit combination, but would take a lot of time. Computers, however, can run searches like this one very quickly. So, the systematic research algorithm is useful part of some computer programs. Next, we look at heuristics and biases. In this, we will be seeing first what is heuristics. The study of heuristics in human decision making was developed in 1970s and 80s by psychologists Amos Tversky and Daniel Kahneman, although the concept was originally introduced by Herbert A. Simon. We make decisions and judgments every day. If we can trust someone, if we should do something or not, which route to take, how to respond to someone who is upset, the list goes on and on. If we carefully considered and analyzed every possible outcome of these decisions and judgments, we would never do anything else. Unfortunately, humans aren't as fast as computers and need some other way to narrow down the possible solutions to only a few. Thankfully, our mind makes things easier for us by using efficient thinking strategies known as heuristics. A heuristic or rule of thumb is a simple rule that is intended to apply to many situations, whereas an algorithm is very specific and will always lead to a solution. A heuristic is an educated guess based on prior experiences that helps narrow down the possible solutions for a problem. For example, if a student is typing a paper in a word processing program and wants to know how to format the page, he or she would try to read an entire manual of the word processing program. That would take a while. Instead, the student could type format into the help features search program or click on the word format on the toolbar. Doing either action greatly reduces the amount of information the student will have to look at to get an answer. Using the help feature or clicking on the appropriate toolbar word will also work for similar programs. Psychological heuristics are models for making inferences that rely heavily on core human. People often use heuristics in everyday life because they have found them useful, though they are not always dependable. Causality heuristics is where people estimate the probability of a situation by the strength of the causal connection between the events in the situation. The common uses of heuristics are: heuristics play important roles in both problem solving and decision making. When we are trying to solve a problem or make a decision, we often turn to these mental shortcuts when we need a quick solution. Psychologists have suggested a few different theories for the reasons that we rely on heuristics. Attribute substitution. These theories suggest people substitute simpler but related questions in place of more complex and difficult questions. Effort reduction. According to this theory, people utilize heuristics as a type of cognitive laziness. Heuristics reduce the mental effort required to make choices and decisions. Fast and frugal. Still, other theories argue that heuristics are actually more accurate than they are biased. In other words, we use heuristics because they are fast and usually correct. Now we will see some of the types of heuristics. Most of the time, heuristics are extremely helpful, but they can lead to errors in judgments. There are several different categories or types of heuristics. The first one is availability heuristics. Availability heuristic involves making decisions based upon how easy it is to bring something to mind. When you are trying to make a decision, you might quickly remember a number of relevant examples. Since these are more readily available in your memory, you will likely judge these outcomes as being more common or frequently occurring. For example, if you are thinking of flying and suddenly think of a number of recent airline accidents, you might feel like air travel is too dangerous and decide to travel by car instead. Because those examples of air disasters came to mind so easily, the availability heuristic leads you to think that plane crashes are more common than they really are. However, there are many situations in which the availability heuristics is useful and accurate. For example, it's part of what makes us careful in dangerous situations. If we can think of a similar situation that ended badly for someone else, we are more likely to be cautious and better protect ourselves. The next type is representative heuristic. The representative heuristic involves making a decision by comparing the present situation to the most representative mental prototype. When you are trying to decide if someone is trustworthy, you might compare aspects of the individual to other mental examples you hold. A sweet older woman might remind you of your grandmother, so you might immediately assume that she is kind, gentle, and trustworthy. If you meet someone who is into yoga, spiritual healing, and aromatherapy, you might immediately assume that she works as a holistic healer rather than something like a school teacher or nurse, because her traits match up to your mental prototype of a holistic healer. The representativeness heuristic causes you to classify her as more likely to work in that profession. The next type is affect heuristics. The affect heuristic involves making choices that are influenced by the emotions that an individual is experiencing at that moment. For example, research has shown that people are more likely to see decisions as having benefits and lower risks when they are in a positive mood. Negative mood or negative emotions, on the other hand, lead people to focus on the potential downsides of a decision rather than the possible benefits. The next type is anchoring or adjustment heuristic. This is a tendency to judge the frequency or likelihood of an event by using a starting point called as an anchor and then making adjustments up or down. When people make quantitative estimates, their estimates may be heavily influenced by previous values of the item. That is, it is not an accident that a used car salesman always starts negotiating with a high price and then works down. The salesman is trying to get the consumer anchored on the high price so that when he offers a low price, the consumer will estimate that the low price represents a good value. The problem with anchoring and adjustment is that if the value of the initial anchor is not the true value, then all subsequent adjustments will be systematically biased towards the anchor and away from the true value. However, if the anchor is close to the true value, then there is essentially no problem. Now, we look at the summary of this chapter. Problem solving is something that we go through on a daily basis. As problems never end, the need to solve them is also everlasting. From managing your books properly on a shelf to deciding the next step for your career, the problems can be small or big, but they need to be solved on daily basis. Study in cognitive psychology has definitely made our lives easier to some extent. There are concrete psychological steps involved in problem solving, which, if properly followed, can help us tackle every sort of problems. One of the important aspects of solving a problem is forming a good strategy. A strategy might be well thought of, rigorous and a sure winner, but might not be viable given the resources available in hand. This is the end of part 1. We look into some more concepts in the next session.